Hi class, this is Math 2003 Applied Calculus class, lecture 1. In this lecture, in this first lecture, um, I'm going to discuss some prerequisites. It's on your book 2, it's under section 0. Section 0. Review basics. So in this section 0, I'm going to review uh, basics, which is uh, basic and intermediate algebra. Right? So these topics I'm going to discuss, it's not appear on your syllabus, the syllabus I gave you, uh, but these basic topics are very important understanding these concepts in applied calculus class. Okay, first thing, I'm going to discuss a little bit about solving linear equations. You guys pretty familiar with this topic? Solving linear equations. Writing shortened forms. In future, for equations, I write in short EQ. On top, I write little n. Right? Equations. Okay. Now, we already discussed this topic in the class, but I'm going to go over. I believe you guys pretty familiar with this topic, and it is not hard. The basic principle of a equation is, first of all, linear equation means it is discussing first degree equations, means um, the highest power we discuss is first order. So we're discussing a simple equation, something like x plus 2 equal to 3. Now the principle behind is simple. Equation is just like a simple balance. This is a simple balance, balancing at this point. If we put something here and equal weight on the other side, it is balanced. Now if you put something here, the balance break and this side go down. To avoid that, you have to put the same amount on the other side. So in first figure, I drew a circle and a kind of rectangle here. What I mean is you have to put the same weight, maybe in a different shape. Though they are in different shape, they should be with the same shape, same weight. They are with different shapes, but they should be same weight. Now this is the simple principle we're going to use. Whatever we put here, we have to put the same thing on the other side to keep it in balance. Now if you put negative 2 on the left side, you have to put the same thing on the right side too. Some of you guys may wonder, I'm sure you are not, but basic classes, why I put it in a different line. It's in the same line. you can assume it is in the same line like this. We put negative 2 to this side, negative 2 to the other side. Why we do that? To get rid of this positive 2, right? Then we get the answer x equal 1, right? I'm discussing this linear equation in detail, so in future when we start doing this, in this type of situation I directly write x equal to 1 without writing this negative 2 on both sides, right? So that's a simple equation. Now I'm gonna change this equation. I write extra number here. Say if we have 3 here, when we minus 2 on both sides, we get 3x equal to 1. Now our intention is to solve this equation for x. Solving for x means isolate x on one side. Now how we get rid of this 3? We have to divide both sides by 3. Means this 3 multiplies x, therefore we have to do the inverse operation. The inverse operation of multiplication is division. Here this 2 adds to x, that's why we did minus 2. Inverse operation of plus is minus. Here inverse operation of this multiplication, between 3 and x we have multiplication, we do division. Then we get the answer x equal to, this 3 to 3 cancels out, we get x equal to 1/3. Right? Now means in solving for x, what we want to do is isolate x on one side. For that, you may move x's to one side. Now in more complicated situations, x term appear more times. Let's do something like that. Okay, now x appear on both sides, numbers appear on both sides. When I say x term, this is x term, x with a number, but it is single term, a number, x term, a number. Now we first thing we have to do is move x terms to one side and numbers to the other side. Now there is no convention, means we can move x term either to the left side of the equal sign or to the right side of the equal sign, doesn't matter. But if we keep doing the same thing, that would be easy. So let's do this. Always let's try to move x's to the left of the equal sign and numbers to the right side of the equal sign. Right? So we want to move x terms to the left, so we need this, we keep it. Number 5, a number, we don't need it on the left side, we want to move it to the right side, therefore we minus 5 on both sides. Now we are here. What we do is we go term by term, we scan the equation from left to right. First we were here, we need this, we didn't do anything. Then we were here, we see it's a number, we don't need it, so we minus 5 on both sides. We are here, then we pass the equal sign, go to the other side, we see an x term, we want it on the left side, we don't need it here, therefore what we do, we minus x on both sides. We are here, Then we go to the next one, we see number 7, it's a number, we need it there, right? Then simply combine these two lines, we get 2x, these two cancels out, equal to these two cancels out, 7 minus 5 is 2. Then to get x by itself, we think what operation is in between 2 and x, it is multiplication. The inverse operation is division. We divide by 2, we divide by 2, we get x equal to 1, right? Now x equal 1, this is the final answer. Now as we move on, you will see some fractions. It is again not different. That if you have any difficulty with fractions, please let me know. I will do another video, or I will discuss in class. I'm gonna erase this. I will discuss few common techniques. We did a couple of questions, so I do this as third example. If we have 2 over 5x equal to 12, now look, the question is to solve for x. What do you think? Some may suggest to do cross multiplication, but if you think a little bit about what I told you before, you think what this 2 over 5 does to this x and how we get rid of that. Now you see this 2 is multiplying x. What 2 does to x? 2 is multiplying. Between 2 and x, it is multiplication. Between x and 5, it is division. This line continues. You can imagine this line continues. So 5 is, x is divided by 5. To get rid of this 2, you can write 2 in the denominator, 5 in the numerator. Now if you multiply by this factor, this 2 to 2 cancels out, 5 to 5 cancels out, right? Then according to the basic principle we discussed, the balance, whatever you do here, you have to do the same thing here. Means we multiply left side by 5 over 2, we have to multiply right side also 5 over 2. Then this side cancels out, we get x equal to, if anything cancelling out, do that. Cancelling means dividing. We can divide 12 by 2, 2 times 1, 2 times 6, 6 times 5 is 30. Right? You can do it if and only if you have one term on both sides of the equal sign. One term on left side and one term on right side. Originally we had 2 over 5x on the left, right side we had 12. One term, that's why we could do it. If we had more than one term, you cannot do it. Let's see this example. can we do the same thing here? Except here on both sides and it has fractions. To get rid of this 3 over 4, we can multiply this by 4 over 3, but it make it complicated on the other side. When you multiply this by 4 over 3, you cannot get rid of this fraction. Fraction means the denominator. If the denominator is not 1, it's a fraction. Then it makes the problem worse. Now for this type of questions, what we can do is we can multiply the whole equation by the least common denominator. In this case, which is between 4, 2 and 4, here it is 1. We can multiply whole equation by 4, which is the least common denominator. Multiply by 4, multiply by 4, multiply by 4, multiply by 4. The entire equation, the left side and right side, we have to multiply with the same number. Then this to this cancels out, we get 3x. 2 goes into 4 2 times, minus 2 equal to 4 cancels out, we get x plus 12. Then, like I think question number 2, we move letters to the left and numbers to the right, letter terms. 3x and x, we want to move them to left side. For that, we scan through the equation. 3x, we need it on the left. Negative 2, we don't need it. To move it to the other side, what we do, we plus 2 on both sides. To get rid of this negative 2, we add 2 to both sides. Then we go to the other side, x term, we don't need it on the right side, so we minus x, we are here. Then we go to the next element, which is number 12. We need it, it's a number, so we need it on the right side of the equal sign. Then combine these two lines, we get 2x. This cancels out, these two cancels out, 12 and 2, we get 14. Dividing by 2, we get x equal to 7. See, I didn't write divide by 2, so we have to accelerate little by little. You have to be familiar. It doesn't matter you write divide by 2, but try not to do it. If you're willing to do it, that's fine, but to make it fast and to make it less complicated, when you're doing big questions, those extra steps makes the entire thing big and it looks complicated, right? Alright, so that's it. That's the final answer. So basically that's it for solving equations, linear equations. Now I want to discuss two special cases. X minus 4 equal to 2x minus 4. Now in this case, if you do the same thing to move x's to the left and numbers to the right, what we got to do is we plus 4 then to get rid of this, we don't want to get rid of this 2x, we want to get rid of this 2x because it's on the right side. So minus 2x minus 2x. Then what happened? Then everything cancels out. Then we get 0 equal to 0. What does that mean? This means for any x value, this equation satisfies. Plug some numbers and check. If you substitute 2 here, 3 here, you have to say substitute the same number on both sides, you get the same answer. That means many solutions, more than one solutions. Right, now second case is I get the same example but little bit different. Minus 4 equal to 2x plus 6. Now if you want to solve, you want to move this 4 to the other side. Plus 4 plus 4. Move this 2x to the other side, minus 2x minus 2x. Then what happens? This side all cancels out, and we get 0 here equal to these two cancels out. These two not cancelling out, we get number 10 there. We get 0 equal to 10. Can this be true? Can this be true? No, that cannot be true. That means this has no solution. Okay, now if you, this is what it mean in short. If you get the same number on left and right side, which is a true result, this is true result. Therefore it has many solutions. Here 0 is not equal to 10, therefore it has no solution. This not necessarily 0 equal to 0. You may get answers something like, if you get answers something like 2 equal to 2, negative 10 equal to negative 10, such answers, that means still many solutions. Right? Here other examples are, if you get anything different, 2 equal to 7, 5 equal to negative 4, still no solution. Okay, if you get false answers, this is not true, this is false. If you get false result, that means the original equation has no solution. Okay, let me see what else. Okay, basically that's it for solving equations, linear equations. I'll tell you how to do it in calculator. Not this type of simple equations. If the equation is very big and complicated, you can use calculator. You know, here we use TI-89. So the tips I'm giving you from TI-89 calculator. First thing is you can go to catalog. there is a button in your calculator, catalog. You press that, then go to solve. To do this, first you should in home screen. Okay, first home, from that you go to catalog, then go to solve. Then you once you press solve, you get this this command, right? Then you type whatever you want to solve. 2x plus 5 equal to 7 comma x. This means solve this equation for x, right? Then this is enter sign. I use this is enter. This is enter key, which is at the very bottom of your calculator, right? Okay, now this is the problem. If you get invalid answer, just simply say error, right? Now in future when we solving quadratic equations, etc., you will see we get imaginary answers. When we get imaginary answer, it will say error. Simply it say error. But we would like to know if there is a complex numbers and complex number answers, right? Imaginary numbers. For that, use this one. First of all, you should in home screen, then go to catalog, then instead of solve, you go to C solve. The C stands for complex solve, and you do exactly the same thing. You type the equation as it is, 2x plus 5 equal to 7 comma x, and enter button, right? Now you may wonder, how do I know which one to use, solve or C solve? How do I know if I am going to get complex answer before I enter this to the calculator? Okay, the simple answer to that question is use C solve always, right? If you have real answers, this will give you real answers. If it has complex answers, this C solve give you complex answers too. For example, two plus 5i, right? Real part, the imaginary part. Example for real, this is complex. Simply number 2, number 3, number 5, such answers. Example for complex answers, 2 plus 5y, something like that. Mean if the equation has complex answers and if you use solve, it will give you error message. But if you use C solve, if the equation has real answers or complex answers, it will give you either one, right? Therefore I suggest you use C solve always. Alright? Okay, what else? Okay, these are the calculator tips. Now let's see solving quadratic equations. Quad means 2, so second order equations, the highest power is 2. For instance, if you have something like this, 5x square minus 20x equal to 0. So first factor this out. Okay, let me to show you something else. Let me do this. So you get this 20x, 5x square equal to 20x. Okay, as we learned, we can use the principle of balance. We can divide both sides by 5. That's fine. We get 5 times 1, 5 times 4. That's fine. Now we see x square and x. The question is, can we divide both sides by x? At a glance, some of you may say, yes, we can do divide by x. But the thing is, when we dividing, okay, first of all, I will ask you a question. Say we have number 4. Can we divide this by 4 and this by 0? If you divide anything by 0, the answer is undefined. Okay, or infinity. So that means we shouldn't divide by 0. But in this case, if you divide it by x, you make an assumption. You assume x is not 0, which we do not know, right? Therefore, it is not fair you divide by x. In fact, you will see x equals 0 is one of the answers, right? Now we get x square equal to 4x. Then we move this 4x to the left. X square minus 4x equal to 0. Take x as a common factor. We get x minus 4 equal to 0. Now we use zero product rule. That means we multiplying two things. If the product between two things equal to 0, we use zero product rule, which means each term is equal to 0. This arrow means this means x equal to 0 or x minus 4 equal to 0. This term equal to 0 or this term equal to 0. What is called? This is called zero product rule. Okay, zero product rule. So one of the answers is x equals 0. We can solve this one, x minus 4 equal to 0. That means x equals 0 or x equal to, take this 4 to the other side, positive 4. first example under quadratic equation. I'm gonna erase this. I'm discussing different types. Say you have (16x squared minus 12 equal to 0). Now looking at this, you may suggest me to take the common factor out. Yeah, we can do it, but the thing is, here you see it is different from the previous question. Previous question was, I cannot remember the exact question, 5x square equal to, I think it was 20x, right? Now you see the difference between these two. Here in both cases we have two terms. If you move this to this side, you get minus 20x equal to 0. It looks similar. They both have two terms, but the difference is the first term is with x squared, the second term, this has x, this does not, right? When only one of the terms has x squared and the other term is just a number, you don't have to do that much of work. What you could do is simply move the number to the other side, isolate x squared term. Means you can do this only if x squared appear with only one term. Then you get 16x squared equal to 12. Isolate x squared equal to 12 over 16. Simplify this, 4 times 3, 4 times 4, then get the square root. X equal to, when you get the square root, remember you have to use plus or minus. Plus or minus square root 3 over 4 equal to plus or minus square root 3 over 2. Square root of 4 is 2, right? Why we get plus or minus? Because if you square 2, we get 4. If you square negative 2, you still get positive 4. If you square any of these, you get the same number 4. Therefore, square root of 4 is either positive 2 or it could be negative 2. Right? Okay. Third type. Okay, if you have quadratic equation like this, 6x squared minus 7x minus 3. Now we can, to solve quadratic equations, basically we have two methods, factor by three methods actually. We can solve this by factoring. We can use quadratic solution formula or completing square method. So we can do it in either way. So let's first do it by factoring. Usually if it is not possible to do by factoring, they ask you to use formula or completing square method. TING, completing square method. Okay, let's first do by factoring. For that, we multiply this and this. 6 times negative 3 is negative 18. This is called AC method. Then find two factors of negative 18, that gives us negative 7. Negative 9 times 2. Negative 9 times 2 is negative 18. If you add them, if you combine negative 9 and 2, if you add these two, you get negative 7, which is this number. Right? Then that means we can split this middle term into two terms according to this. 6x square minus 9x plus 2x minus 3 equal to 0. Now we have 4 terms. Before we had 3 terms. We had 3 terms. By splitting the middle term, now we have 4 terms. When we have 4 terms, we can do factor by grouping. These two, 6x square and 9x, what's common? We can divide both by 3, both by x. 3x times 2x minus 3. From these two we can take out 1. Then 2x minus 3 equal to 0. Now we have two terms, this and this. We have two terms. For both terms we see this part is common. Therefore take that out. When you take that out, we have what's remaining from first term. 3x is remaining. When you take out this part, what's remaining from the second term? Plus 1 equal to 0. So we factored it. Now we have product between two terms. See two parentheses, that means in between what we have, multiplication. We have product between two things, therefore we can set each to 0 according to 0 product rule. We can say either 2x minus 3 equal to 0 or 3x plus 1 equal to 0. Here we get x equal to 3 over 2, or here we get x equal to negative 1/3. Right? So we get two answers. When we solve quadratic equation, we get two answers. If you solve third order equation, third degree equation, we get 3 answers likewise. Right? Okay, to learn the method, let's solve the same thing. I change the number to 4. by using quadratic solution formula. Okay, what's the quadratic solution formula? X equals the solution to, I write it on the side, ax square plus bx plus c equal to 0. Solution to this equation, x square plus bx plus c equals 0, is given by is x equal to negative b plus or minus b square minus 4ac square root whole thing divided by 2a. Right? Solution to this given by this equation. I write it again here. Now if you compare these two equations, your a is 6, b is negative 7, this is your c. Right? Okay, let's substitute. Negative b is negative 7 plus or minus, my sincere advice to you in substituting is substitute in parentheses. Whatever you substitute, put it in parentheses. Square root b square negative 7 square minus 4 times a is 6 times c is negative 3. Divide by 2 times a is 6. Seven plus or minus square root of 49, negative and negative positive, plus 72 divided by 12. 7 plus or minus square root divided by 12. I write these two answers on the side. 3 over 2 negative 1/3. This is to compare. Then we get x equal to square root of 121 is 11. 7 plus 11 divided by 12 plus or minus. With this we get, with plus we get x equal to 7 plus 11 is 18 over 2. With minus we get x equal to negative 4 over 12. This is equal to 12. We can divide both by 6. 6 times 2, 6 times 3, 3 over 2, 4 times 1, 4 times 3, we get negative 1/3. So these two are the answers which are same. Okay, we get the same answer using quadratic solution formula. Right, now I'm going to erase this. Change this number to 5 completing square. Alright, we're going to solve the same equation by completing square method. First of all, to use completing square method, the coefficient of x square should be 1. Divide the whole equation by 1 by 6. We get x square minus 7 over 6x minus 3 over 6 equal to 0. Then move the constant term to the other side. X square minus 7 over 6x. I keep some space here, equal to 3 over 6. Right? Now what I'm going to add, I'm going to add the same term to both sides. What I'm going to add square of half the coefficient of x. Coefficient of x is this, half of this is, how we get half? Half of a fraction, multiply the denominator by 2. That's how we get half of a fraction. Negative 7 over 12. We add that to both sides. Then left side we get a complete square. This is a complete square of x minus 7 over 12. When you square this you get plus here, therefore check this out, minus 7 over 12 whole thing square. This should gives you this side equal to this side. We can simplify. Here we get 3 over 6 plus 49 over 144. Six times 3 times 24. plus 49. One 44, right? When we add these two, we get 121 over 144. Now we can get the square root on both sides. Then what we get? X minus 7 over 12 equal to, when we do square root, remember we have to do plus or minus, 11 over 12. Then with plus we get x equal to 11 over 12 plus 7 over 12, which is what? 18 over 12 which is 3 over 2 divided by 6, okay? Or with minus we get x equal to negative 11 over 12 plus 7 over 12, this is negative 4 over 12, negative 1/3. Again we get the same answer, right? Okay, we solve the same quadratic equation by 3 different methods and we end up getting the same answer, right? I'm going to erase this. Okay, now let's solve this one. Eight x to the power 3 over 4 minus 19 x to the power 3 over 8 minus 27 equal to 0. Now at a glance this equation looks horrible, isn't it? This is a fractional and this is a fraction. Exponents, they both are fractions and they're not the same. It looks horrible, right? But if you think a little bit, now if you square this exponent 3 over 8 means three over 8, if you square this, what do you get? If you simply square denominator, you get 3 over wait, I said the wrong thing, I take it back. Now get the whole thing, x to the power 3 over 8. If you square this, right, when you square, what you do, you multiply only the exponent by 2. If you multiply this by 2, what you get, x to the power 3 over 4, right? Is that right? If you what I did, I took this one, x to the power 3 over 8, I square it, we get x to the power 3 over 4, which is this one. That means this is the square of this. Understand? Therefore, can we write this? 8x to the power, in place of 3 over 4, can I write 3 over 8, this to the power 2? I don't do anything to this one. 19x to the power 3 over 8 minus 27 equal to 0. Get it? Means if you square this, 2 goes into 8 4 times, we get 3 over 4, which is this one. Right? Then we see same thing here and here. Let me show you it in a different color. And let's do this. Let's use a different letter for this term, x to the power 3 over 8. Let u equal x to the power 3 over 8. Then we get 8u square minus 19u minus 27 equal to 0. Okay. You know how to factor this one. I'm not going to do it again. 8 times 27, get that number, then find two factors, that gives you negative 19. We can factor this out. I directly write factors here. 8u minus 27 u plus 1 equal to 0. This gives us u equal to 27 over 8, or u equal to negative 1. Is this the answer? No, there was no u in the original equation. We have to resubstitute this. We substitute u equal to this. Now you have to reverse substitute. U is x to the power 3 over 8. U is x to the power 3 over 8 equal to 27 over 8. Then to get x equal to 27 over 8 to the power 8 over 3. If this is 3 over 8, the answer to x is given by this to the power 8 over 3. You can use calculator to find this number. This is 256. This one, this gives us x to the 3 over 8, u is x to the 3 over 8 equal to -1. X equal to -1 to the power, we do the same thing, 8 over 3. This is an even power, 8 power, therefore this should be +1. Getting 1/3, it doesn't matter, it is still +1. Okay. Now the good thing is, if you going to use the calculator, you can use the same thing I told you in section 0.1 at the very beginning. Means you type C solve this equation, comma x, right? It gives you these two answers, right? And here I want to tell you something. If you're using calculator, when you get this, if you want to find the approximation, means if you want to get the number that when you divide this by this, you can simply do this. Let me write in a different color. Calculator. You have green diamond. It is in green diamond, and then click enter. Then it will give you answer in decimals, right? Okay, what else? That's all about quadratic equations. Do more questions. There are questions in book. If you're good at it, don't worry about it. If you still have trouble, do few other questions from the book, section 0. And if you're having more trouble, let me know. Email me, right? Again, when you email me, use the Baruch email address. Otherwise, I'm working in a different college to have from that, use this email address. himal.senarat DENIY-01 NIYA at baruch.uni.edu. Okay, Himal dot SENARATH BOOKOLADENIYA at baruch.cuny.edu. Do not use Queen's email address. It has a Queen's email address. Do not use that. Use only this one, right? If you use that Queen's email address, it's going to my other email there, so I do not expect that in the other college, right? So please send it only to Baruch email address. If you have any questions, right? Okay, what else? Solving nonlinear inequalities. You may wonder what inequality means. This sign, right? Now, what is linear inequality? Again, same thing. If you have the highest power of x is 1, it's a linear inequality. Then you do the if you have, this is a linear inequality, you isolate x minus 5, it gives us 2x. This is an example. Greater than negative 2 divide by 2, you get x greater than negative 1. Then what you do is you do the number line. This is the number line going from negative infinity to positive infinity. All real numbers, you mark only this number. This is all you have. This is negative 1. X is greater than negative 1, means greater than is always to the right. This means from here all the way to positive infinity, all numbers. So if you write it in interval notation, this is negative 1 to infinity, right? So this is the answer in interval notation. This is not included because x is greater than. You shouldn't shade this circle. Since it is not shaded, this parenthesis is, this should be a parenthesis, not square bracket, not this. On the other side is going to infinity. Infinity is not a definite number, therefore you shouldn't use square bracket. You have to use parenthesis to indicate indefinite number, infinity, right? Now just to show you with the equal sign, I change the number to number 2. Equal, this doesn't change. Let's do a different one. Say I change this also to show you something. we get negative 2x greater than or equal to negative 2, then divide by negative 2, divide by negative 2. As soon as you divide by a negative number, this inequality flips. X less than or equal to 1. Then what happened? You have, this is infinity area, negative infinity, positive infinity. You have 1 here. Since you have equal sign, you shade the circle. X is, always read the inequality from the side of x. X is less than. Less than is to the left. Less than 1. So it is this way. What this means is from here, including this number, all the way to this end, negative infinity. So answer in interval notation is, you always start writing the answer from left side. So the leftmost number that you could get is negative infinity. Negative infinity up to positive 1. Positive 1 is the last number. You do square bracket y, this answer is included. Negative infinity, you not include that because it is indefinite number. Infinity, negative infinity to positive 1, since it is shaded, we do square bracket, right? So this is the answer. Okay, let's do another question. Okay. So let's do this question, which includes most of the things regarding these inequalities, including sign analysis. Divide by x square plus 7x plus 12 x square minus 9 greater than or equal to 0. Okay. This is the question. 4x to the 4x cube minus 4x times x minus 3 divided by x square plus 7x plus 12 times x square minus 9 greater than or equal to 0. The first thing, the first step, what you should do is factor. Factor everything, both numerator, denominator, whatever you can factor them out. So here you see we can take one x out with the x, with this 4 x to the power 4, it becomes x to the power 5. 4x to the 5 x square minus 4 x minus 3 divided by this one, factors of 12, that gives us 7 is 4 times 3 is 12, 4 plus 3 is 7. X square minus 9, difference between two perfect squares, greater than or equal to 0. Still I see we can factor this. Four x to the 5 x minus 2 x plus 2 x minus 3 divided by x plus 4 x plus 3 x minus, okay, x plus 3 and x plus 3, that we can write as x plus 3 square x minus 3 greater than or equal to 0. Now as soon as you see this x minus 3 on numerator and denominator, some people like to cross them out. In the same reason what I said before, if you cancel out x minus 3, you assume x is not equal to 3. You shouldn't do that assumption, because you don't know if x minus 3 is 0 or not, which means x equal to 3. In fact, why we need these inequalities, mostly we use this when we do functions, right? So first step is factor, then you assume this part, what on the left side. On the right side you have to have 0. If not, move everything to the left side. Simplify everything on the left side and factor as much as possible. Do not cancel out, do not simplify this, do not cross out top and the bottom, right? The reason is when x minus 3 equal to 0, x equal to 3. When x minus 3 equal to 0, x equal to positive 3. So this function has a hole at when x equal to 3. We say, I'm going out of the topic. Our job is to solve these linear inequalities. What I'm telling you is why you shouldn't cross this out. Function has a hole. This topic we're gonna discuss later on. When time comes, we will discuss about this. At x equal to 3. So there the function will go like this. It has a hole. That means at this hole means at this point it is not defined. This is x equal to 3. It is undefined at this point, but it continues before that and after that point. It is defined before 3 and after 3 it defined, but when x equal to 3 it is undefined. Okay, now this is not the thing we want to discuss at this basic stuff. We want to solve this linear inequality. So we shouldn't cancel out top and the bottom. Now next step, find boundary values. Right? Boundary values means set numerator and denominator both to 0 and find x values where numerator is 0 and denominator is 0. If numerator is 0, the whole function is 0. 0 means a defined number, but if the denominator is 0, for instance when x equal to -4, x equal to -3, +3, the function is undefined, right? Now you see, okay, top equal to 0 when, now since it is all factored, just looking at this we can say when x equal to 0, when this is equal to 0, x equal to 0, when this is equal to 0, x equal to 2, -2, comma 3, right? Bottom equal to 0 when x equal to -4, -3 and 3. Now you see common number top and the bottom 1 time 3. When x equal to 3, what happened if the function is 0 or undefined? This means function equal to 0. This means function undefined. Okay, undefined, no, not defined, same thing. Right, now here you see 3 is on top and the bottom. When same number appear on top and the bottom, you give priority to the bottom. Means when the function is undefined, it cannot be 0, right? Therefore when x equal to 3, function is not 0, function is not defined. Usually when top is 0, function is 0, but if at the same number where top equal to 0, bottom also 0, then you say function is not defined. Okay, right, now let's see what we can do next. At this point you may cross this 3 here, because at x equal to 3, it is not, function is 0, function is undefined. Now we're going to put that on the number line. I'm gonna erase this step. Okay. I'm gonna put all these numbers here, top and the bottom. The smallest number is -4, -3, -2. After that, 0, 2, 3. Okay, now we know at this point what's happening to the function. At this point, -4, whenever it appears in the denominator, it is undefined. -4, -3, 3, -4, -3, and 3 function is not defined. Right? First we look at the denominator. Everywhere else, 0, 2 and -2, these three numbers, the function is 0. Right? What I mean function, we assume this is a function. Okay, we assume this is a function, say fx. This function is not defined at these points, but 0 at these points. We want to find out. Don't forget the question. We want to find out where it is greater than or equal to 0. That's our non-linear inequality. Why it is called non-linear? See, it's the highest power is not 1. It is different, and it's a fraction. It's a rational function, right? It's a rational function. Okay, now at these points it is not defined. Here it is 0. Where it is greater than 0, since this is 0, we cannot say here it is greater than, here is less than. We don't know, right? Or vice versa. We cannot say here it is positive, here in this side function is negative. Means function means when we draw it, it's a function. It's a graph, right? So bottom we see the exposition, exact exposition on top. We showed if the function is not defined or 0. Now this is what we're gonna do. To find what's happening in between these points and outside of these points, we use a check value. For this test value, test number, any number less than -4. Okay, the main idea is this. If let's get a certain period, says between 0 and 2, if the function is positive, it is positive. If you find if you by substituting a number, if you find this is positive, it cannot be negative in between anywhere else, right? Here it is 0, here it is 0. That means in between the function is any shape, something like this. Okay. If you find one point is positive, the function is the whole thing between these two is positive, means above this x-axis. Right? You may assume this is the x-axis. Right? Now, keeping that in mind, let's use a test value. between less than negative 4, we can use negative 5. I write in different color. Negative 5. Between negative 3 and negative 4, we can use negative 3.5. Negative 2 and negative 3, negative 1. Here, wait, negative 2 and negative 3, we have to use something like negative 2.5. Between 0 and negative 2, we can use negative 1. Here, between 0 and 2, it is 1, 2 and 3, 2.5. Greater than 3, you can use number 4, number 5, anything like that. Okay, let me write these numbers. In red. ND 0, 0, 0, again 0. These are function. Function value. These are function values. Not defined. At this point, function values are these. Not defined, 0, 0, 0. Right? There is another one here. It is undefined, not defined, ND. Okay. Now the next thing is you have to substitute this number, this test number here. Here it is. It looks hard, but it is not hard. I will do one with you. You substitute negative 5 here, and you don't need the value. All you need is the sign. If it is positive, this whole thing, or negative. Let's do one of them together. Let's substitute negative 5 here. When you substitute negative 5 to the 5th power, it is negative. You simply write the sign. Negative 5, negative 2, it's negative. Negative 5 plus 2 is negative. You don't write the number, just write the sign. Negative 5 minus 3 is negative. Bottom, negative 5. When you put it here, it's negative. Negative 5 plus 3 is negative, but when you square, it is positive. Negative 5 minus 3, again it is negative, right? So in this parentheses, numbers you getting with these signs, right? Now we can find the overall sign. The easiest way, calculate number of negatives 1, 2, 3, 4, 5, 6. Calculate number of negatives, negative signs. If the number of negative signs are even, it is positive. If number of negative signs are positive, number of negative signs are odd, it is negative. Why? Think a little bit, and if you couldn't figure out, ask me. I try to tell you in simple. If you multiply 2 negative signs, it is negative. If you multiply 3 negative signs, it is again negative. Same thing if you divide if you divide by now negative and negative, positive, positive and negative, negative, negative divided by negative is positive. How many negative signs? 4 negative signs. Multiply or divide doesn't matter. If you have even number of negatives, if it is positive, here you have 1 2 3 4 even number, it is positive. Odd number 1 2 3 4 5, it is negative, right? That's the simple explanation. Think about it. If you have doubt, let me know, email me, right? Now overall sign when you do this is negative. That means less than 0. Same thing. Negative or less than 0, they both means the same thing. One, two, three, four, five, six. 6 negative signs. Therefore, this should be positive. That means it is greater than 0. Right? Once you do it, find number of negative signs. 1, 2, 3, 4, 5, 6. Even number. Therefore, it is positive. Right? Now, with that, we can say the sign. Okay. Let me see if I have a different color. Okay. With this technique, find this. I found it earlier. I write the sign. In this region, it is plus. This region, it is minus, minus. Between 2 and 3, it is plus. This green sign shows when you substitute what sign you get. In this region, it is plus, minus, 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 plus, plus. Right? Now we almost done. I'm gonna erase this. Now to write the final answer, what we need is this line, the number line, our x-axis, and this green signs. What we need, where it is greater than 0 or positive. Wherever we see positive, that's exactly what we need. Right? In doing this, it would be easy with these circles. This when function value 0, shade it, then you make no mistakes. Right? Now we can write the answer. It is positive from negative infinity to negative 4, negative infinity to negative 4, union means or, 2 comma, here it is positive, after that it is positive here, that means 2 to 3. 2 is shaded, therefore we have to use brackets. 2 to 3 union. Now 3 is not shaded, that's why I use parentheses. Now I have to use this region. 3 to infinity, 3 is not shaded, therefore parentheses. 3 to infinity. Infinity is indefinite number, so use parentheses, right? So this is the final answer. Okay, that's nonlinear, solving nonlinear inequalities. Now, the only calculator tip I can give you is this. You have fx. Before, you remember I wrote fx. Enter this to the calculator. Say when you click, let me see the calculator. It's green diamond and Y. This green diamond is here. F1 key, green diamond. When you click green diamond and F1, it shows you this little green sign. It shows Y, right? I show you that one. I might have a lot of graphs there. You click this and F1. There you see this Y1, Y2, Y3. For some calculation, I enter some graphs there. Yours, if you're using first time, yours or everything it would be blank. You can erase them. I'm using these for some reason, so I didn't erase them. So yours should be Y1 equal, Y2 equal. On right side, you shouldn't have anything, right, at the beginning, right? Now, there, go to Y1. You have Y1 equal to, then you enter fx. Type everything in that inequality. Then you have that. Then go to home button. Home key is here. Right below the green diamond button, you have home button. Once you click on home button, you get this. Whatever you typing, this is the calculation bar. It appear here, and it calculate and shows you on the screen. Okay. Now do this, then go to how you go to this. This is green diamond. And enter. You go here, then you enter fx, then you click on home key, then there you enter, then fx is your y1 now, right? You enter y1. If you want to calculate this check value, y1 negative 5, it will give you some positive answer equals to plus blah blah blah, right? It gives you a positive number. You don't need the number, you need only the sign. Then you simply mark this is positive. Means there you can get the sign without doing this as I showed you. That's the only convenience, but that also not a big deal. But if you having trouble or making mistakes using calculator, you can do it in this way. Alright, so that's all about section 0, right? Prerequisite. You have everything more than what you need. I did in this video. So go through this. If you having any difficulties, please let me know. If you have difficulties, you may email me or tell me in a live video. Okay, in live session in class. All right. So take care, guys, and stay safe.